Software. Thanks for joining today's webinar. Today we're going to spend the next hour talking about support lines and splitters and cover some of the nuances with the input of those elements in Adapt Builder. We will record today's meeting and put that on our YouTube channel. There's a playlist for webinars that you can access and share that for any colleagues that might be interested. If you have any questions, you're welcome to enter those into the chat box or reserve them for the Q&A at the end of the training. We'll go about 45 minutes to 50 minutes and then have a 10-minute Q&A towards the end. And we're going to start, this is a two-way slab example. We're going to start by just defining the purpose of support lines and splitters just on a very basic premise and basic example. So I'm going to go ahead and minimize this this model. We're going to open a new instance of the program, and we're going to mainly be using Adapt Floor Pro today. The same concepts and the same principles, really, they also apply to Adapt Mat, and also the ability to generate design strips for RC models where you might have a column and middle strip layout. Those change a little bit between RC design and PTRC two-way slabs. We're also going to talk about beams as well, and how does the program interpret beams. So this is all relative to Adapt Builder 2018 and previous. We are making some fairly dramatic changes for the next release, which is Builder 2019. That is anticipated to be out in August of this year. There's a question, what's the difference between this build 6154 and 6152? This is Adapt Builder version 3, Builder 2018 build 3. The one that you referenced, Marcos, is earlier build. I think it's build 2 or build 1. So we did send out build 3 roughly a week to 2 weeks ago. We send it to the primary contact of all account holders. So if you're not the primary contact, or if you have a specific person designated as the primary contact, you may want to contact them, or you can just email me after the meeting, and I'd be happy to send the latest build to any of those, any of you who have previously updated to Builder 2018. If you haven't updated to Builder 18, then and you're eligible for that, we can also check that and make sure you get updated. So that is the difference with that, Marcos. We'll go ahead, and I'm going to start by just describing kind of what splitters and support lines do. Support lines are essential to actually designing a slab or a beam, or it could be a one-way, two-way slab or beam in the program. So without the use of support lines and splitters, which are used to generate tributaries or design strips, you basically cannot get any reinforcement out of the program, which becomes problematic if you're trying to design. You could still obtain FEM analysis results and look at bending moment contours, stress contours, axial stress contours, etc. But all of those are just raw analysis results that you would then have to use to achieve some method of designing reinforcement for those, which would happen outside of the program. So the purpose of the design strip is to generate design cuts that allow you to process information relative to the slab or the beam, and then the program passes that design cut or design section data to a processor called Designer. It's an executable that's embedded inside a Builder, and that designs those sections for reinforcement, for stresses, and so on. So I'm just going to go ahead here and set up a very basic model, just be something random, arbitrary. So we have something like so. I'll spread that out a bit. I'm also going to add a balcony out on one end here. So I'll just model something like this also. Okay, and we'll add some columns. And I'm also going to add a beam. So we'll go here and add a beam. Now, the beam is, in some cases there's a mysterious notion that Adapt Builder doesn't design beams. And in fact, it does design beams. It's just a matter of how the beam is being processed, and it's really contingent on the setup of the support line. So let's assume we want to design these two strips. This is a two-way slab with an integrated beam in this case. And the purpose of this example is really meant, how do we handle the beam that's continuous, it's part of a continuous two-way slab strip, and how do we handle this balcony? And we're going to mainly use X direction support lines to process this. Let me just open up my marker tool here so we can use this to mark up the slab. I'm going to save this file. Okay. Okay, so we're going to go to floor design. All of our tools that are relative to or pertaining to strip modeling are located in the floor design tab. There's two separate locations. One location, which is strip modeling, allows you to actually model the support lines and the splitters. And the other, on the far end, these are visibility and results icons. So this kind of turns the strips on and off, the results on and off that are related to the design strips. So we're going to mainly be working only in the X direction. Now, if I analyze this slab without any support lines in place, I'll just go over here to analyze and mesh the slab. And the default combination here, or design code, is ACI. We're going to execute the model. And once we execute and we save the analysis, the result browser will show up, and we'll be able to peruse and look at results relative to the finite element solution. So we could always go to analysis, slab. I can look at deflections, actions, for example, moment about X, moment about Y, but this doesn't really give me any information in terms of reinforcement. As a user, you have the ability in version 18 to actually use manual design cuts. If you don't want to lay out any design strips whatsoever within the program, you could go into floor design, and rather than lay out strips, I could create manual design cuts. So I might be interested in a mid-span location on both support lines. I might be interested in this support location, maybe the location along this beam at the mid-span, and another location here. And using these design cuts, which are completely independent of a support line and splitter, you could process these. I could design those sections or investigate them, and I can review results both graphically and also in tabular format. In the result browser, you notice that we have now manual design section results. So I can check deformation on the strip or on the cut. I can check actions for the cut. Okay, this is, for example, the integrated bending moment on this cut. It's 90.92 kip feet. If you were to integrate through the shell elements and the frame elements of the beam, this is the value. Stresses would show up if you had post-tensioning. This is RC at this point. And also you could check capacities, moment capacity, positive, negative capacity, as well as demand and capacity. So you can get the same information for manual cuts as you can for a strip. So this is one option that you have. You could also double click on the cut, and this will actually show you that pretty much the same information in a window dialog here, and also it would show you reinforcement needed at the cut along with capacities. This block that's missing is really the stress information once you add PT to the cut or to the model. So this is one method for getting results out of the model without actually designing or setting up support lines and splitters. Typically, for a two-way slab, we want to cover the slab with design strips. So we're going to want strips in both the X, let's say, and the Y direction. Our primary kind of bending direction, is along this axis, maybe along this axis. So we want to try to formulate reasonable design strips along those primary bending directions, and we need to have some guide for the program to actually generate those strips. So we're going to look at the X direction strips. Now, I'm going to start by just a very kind of an abstract example. Let's say that I want to investigate just a portion of this slab out in the middle of the slab. I'll put a support line from point 1 to point 2 and stop it. The program, when we generate and formulate the design tributaries, we have to generate those based on the location and the presence of boundaries. So when we run the algorithm to do this, we look up and we see a boundary here. We look down and we see a boundary. So that means that when I generate a design cut for this strip, it's going to extend out to the boundary on both top and bottom. And in the other direction, we're looking for a boundary. So we're actually looking along here, and the only boundary that this sees is actually out on this edge. The same thing over here. But in reality, the start and stop of our support line is located at this point and at this point. So we don't want the tributary to leak out into this hatched zone here, and we don't want it to leak into this zone. So we have to include what's called a splitter. We have to impose just a virtual boundary on the model so the program knows, okay, now I've included a boundary. Now the tributary is going to stop. So this, in essence, becomes the full tributary. But I don't want, let's say, the tributary to extend to this slab edge on the top. I'll label that T, or on the bottom. I want it to be, let's say, 5 feet plus or minus away from the support line to the top and bottom. So I would then need to add another splitter here and here. And now I get an enclosed region for my design strip in this example. So if we add these splitters, this support line that I've added is an X direction support line. It's labeled under the General tab, X direction. So our splitters also must be labeled X direction for them to be effective for generating the tributary, for that support line. So we'll go ahead and create an X direction splitter. I'm going to snap it at the end point and just go ahead and snap it. I could snap it out of the slab. I could snap it, somewhere above the location where we're going to have an intersecting splitter. So I'll just snap it out here, press enter. I'll do the same. And you want to be careful about snapping. We want to make sure that we snap precisely on the splitters. So this is my first pass. Let's say we want to generate the strip based on this. If I generate the design strips, I get an extension to the boundary of the slab. But now I'm going to impose 2 more splitters. I'm going to create a splitter that bounds the top and that bounds the bottom, like so. And if I regenerate the strips, now I get the strip cut off like this. Okay, so you can use splitters to mold the tributaries the way that you want them to look and behave. Usually, sometimes there's more complexity involved in a slab that has multiple support lines. If I add a, let me take away this, and I'll go ahead and just delete out the solution here. So we're going to add another support line now. I'm going to add a support line from this slab edge to the column. And remember, this is actually labeled a 2-way slab support line. So now we're kind of getting into the realm of how does this treat the beam. Okay, this support line is labeled as 2-way slab. We designate the design type within the support line properties. All that this does is a couple of things. It based on this criteria setting, we use the code provisions relative to minimum reinforcement for a two-way slab. And the presence of PT would then dictate whether it's a two-way RC slab or a two-way PT slab, and you have different minimum reinforcement requirements because of that. So this is important to dictate how this is defined in terms of its design of minimum reinforcement. For strength design, it doesn't really matter. This could be a two-way slab, it could be a beam. Strength design is kind of independent, let's say, of the criteria. We just satisfy the demand moments just based on the mechanics of the section and the code material models for concrete and for reinforcement and pre-stressing. So those are hard coded into a material file that we use in the program, and when you select the design code, it reads in that material model. So this is important, this criteria. Now we have a situation now where if we look at this same setup, we have a splitter here. So we're going to talk about this splitter right there. We have a support line on the left side. Again, the program is trying to develop a tributary for these spans. There's span 1, there's span 2, span 3, 4, and 5. And for this interior support line, there's only one span. I'll call it span 1. I'll call it 1B. Let's say this is support line A. So on spans 1 and 2 for this continuous support line, again, the program looks vertically and looks below, and it sees a boundary, again, which is a slab. So these cuts are actually going to go all the way through. Once you step over this splitter, now we have some other stuff going on. We have our support line, we have another support line, and they're both bound by splitters, right here and right here. So the program can break this tributary up for the beam in this zone because of the presence of those two splitters. And then for this support line here, again, there's a boundary on the bottom, on the left and right, and this can be broken up like so. So you basically get tributary 1, tributary 2, tributary 3, and then over here you're going to get another tributary 4. And this becomes void. I'll say this is V for void. There's no support line here, so there's no way the program can generate the design cuts because there's no support line in this space. So we'll go ahead and generate the strips. Okay, so here's the first tributary. The second kind of cuts out because of the presence of the splitters 1, 2, and 3. Or actually, we remove that. This is just cutting it in half. And then this gets bound because of this splitter on the bottom. These are all X direction splitters because we're working with X direction support lines. Okay, we'll go ahead and delete that. And we're going to set this up now as it probably should be. So I'll delete all of the splitters. And we have our support lines in place. We have one support line. I'm going to create a second support line down on the bottom. So we'll go ahead and snap on this slab edge. Sometimes I'll actually, rather than zooming in and out of the model trying to snap on that edge, I'll just start a splitter outside of the slab so I can minimize the use of the snap tools, and it just becomes a bit easier. Okay, there's the second support line, and I'll go ahead and generate those. Now in this case we have a situation where we don't need any splitters. The reason we do not need splitters is because this support line starts at a boundary and ends at a boundary. This starts outside of a boundary and ends at a boundary. So there's no need to impose another boundary because everything is extended out to where the program can interpret the extent of the support line. And vertically, it just basically splits this in half. Half goes up, half goes down, and that becomes our set of tributaries for this model. Now you'll notice we're actually missing design cuts in this space for the balcony. And so if I look at the location of these two endpoints of the support line, they stop at the slab edge. So the program can't generate a design cut where there is no support line. If I extend this out like so and like this, then even though this is out in space, when the program looks below, it actually sees slab there, so it's going to create a design cut now in the balcony. So part of this balcony gets taken as part of this tributary, and the other part with the support line below. I would not actually set up balconies this way. I'll show you how we recommend doing that. But this is what happens when you extend this out to cover a projected distance of the balcony. And you can see the tributaries a bit more clean in a different manner if you go to reports and you go to design strips, and we'll look at the design strips in the X direction. So this will give me a nice hatched view of the actual calculated tributary for these two support lines. Okay, let's go back to floor design and I'll delete that. Now for this balcony, I would come back and reestablish these here, and what I'm going to do is add a third support line. Now if this was a two-way slab, we probably would, if I had the program opened in PT in RC mode only, the program would automatically create a middle strip that would go like this, and then you would get a strip like so, and this would extend down and extend down. So to show that, let me go ahead and open the model in RC mode. I'll save this. I'll just reopen and change the mode from PT RC to RC only. And you'll see under criteria, analysis, and design options, there's a option here to automatically consider column and middle strip. If this is set to yes, the program will add another support line automatically. So we'll go back to floor design and generate. You see it's added this middle strip. But again, it only extends to the location of the other two strips. If I turn that option off, then it behaves as it did earlier where you don't get the automatic middle strip. Okay, so let's, I'm going to add another support line, and we're going to add an X direction support line. And usually I'll bring this back either full span or maybe half span behind the balcony. I'll just click on the interface between the balcony and the main slab and then extend it out like so. And now I need a splitter because this point is not on an actual slab edge or a slab boundary. So we'll go to the splitter for X direction, and I'm going to model this boundary. Now the program can properly address this and break this up into design strips. It does a little bit funky because if you look at this, this is my actual column strip, and I have another column strip here, and the program, because I've added this support line here, the program adds between this line, let me mark this, between this line and this line, it adds a middle strip right there. And between the same one on the bottom, it adds another middle strip. And in between the two main column lines, it adds a middle strip below here as well. So you get potentially excessive design cuts in this type of example. I don't think it's incorrect. It's just you could take this slab and break it up into 1 foot design strips and get basically a unit strip along both directions if you wanted to lay your rebar out in that fashion. So all that's happening is you're displacing some of this tributary and this one with this in this box and this box. So you're going to get localized reinforcement when we process this in those two zones. Okay, for something like this, I might actually go back and turn off the middle strip option. So let's say I do want a middle strip from here up to here, but I don't want those two smaller middle strips to be added. So in that case, I have to manually add the middle strip. I'll turn off the option to automatically create the middle strip, and we'll go back to floor design, and I'll just add another support line. So we'll add one maybe that looks like that. Okay, and we'll generate again. It's not going to add middle strips. We manually added it, and you don't get those two small strips between these two regions. So this gives me a better kind of localized set of results for this cantilever and the backspan or half backspan, and I get actual reinforcement for the bending at that cantilever. A lot of times you'll see slabs in our, that come through our support group, and they might have a slab edge, that looks like this. A lot of balconies, and you have a line of columns along here, and so a lot of times we'll recommend users just go in and model support lines that extend down from the balcony, and then you'll have maybe the main support lines out here, and you'll tie those together with splitters like this, and then you get proper, let's say, generation of the tributary. I could even put a splitter here and here, so I get the tributary of this balcony plus the span behind it. The next thing we'll discuss is this beam. I've been talking about it, but I haven't really talked about it, so we'll look at this beam. Now, right now, if I design, let me just add a little bit of load to this slab so we'll get some reinforcement demand. Let me add 20 PSF dead, and I'll add a 100 PSF live. Oops, that's one. I'm also going to go to the reinforcement sizes. If I go to rebar size and material, I'm going to make sure I note the size of the two-way slab and the beam. So the two-way slab is set to number 5s. I'll change the bottom also to a 5, and I'll set the beam criteria to number 8s, top and bottom. So this is important to get this. If I go ahead and I process this design, so we'll go ahead and analyze. This is all being done now as RC with no post-tensioning. If I analyze that and then I go in and let's just design this one strip. If you don't select a strip or just a selection of strips, the program will design everything. If I want to design just this one strip, I could actually just run it and say design those sections here. Okay, so now there's a few interesting things that I'll show you here. First, if I go to design sections and I select design criteria, I look at this and I say, oh, this is great. The program's designing this as a beam. If I look at the criteria of the strip, the criteria actually says two-way slab. And if I produce the reinforcement, or let me do this first. I'll go into a design cut, and under the design section tab, this also says it's being designed as a beam. So that all looks, good, okay, for now. And then I calculate the rebar for the envelope, and this is where some confusion tends to come into play. First of all, the bottom bars for this beam, what we think are the bottom bars for the beam, are number 5s, but we set the beam to number 8s. And you'll notice that the bars on the bottom actually show as being distributed. So this can lead to confusion. The user then wonders, well, are these bars in the slab or are they in the beam? Okay, the program has a setting under criteria analysis design options that is shown here. It says design all beams using the respective building code requirements for beams. And what that means is that whenever a design strip that might be continuous in this case or labeled as something different other than beam, whenever it's snapped on the end point of a beam, at least one end point, it recognizes that as a beam. That's why it's actually designing this section cut as a RC beam, but because the strip is labeled a two-way slab, it's pulling the rebar based on a two-way slab, a number 5 bar. And it's hard-coded to show the bars based on the designation of the support line also, which is a two-way slab. That's why the bottom bars are actually shown distributed, like so. And so if I look at this in elevation, if I take this bottom bar and let's say the beam, let me select the beam first, bottom bar, and under visibility, I'll go ahead and show that one set of components, and I'll turn it on its side just to see what's going on here. So you can see the beam is actually, or the bar is set at the effective depth of that beam, not the slab. So these bars truly are being designed to be in the bottom of the beam, but because of the two-way slab criteria, they're distributed. They're shown as distributed. I could group them, but that doesn't help. You kind of have to know what's happening before you make a change to, let's say, grouping the bars. I could double click and say, well, I'll just show them as grouped, but they're still shown graphically out of the beam. So how can we make this more direct? So we designed this as a beam. We designed the other two spans as a slab. There are ways to do that, and it requires the user to break up the support line. So we'll go back. I'll turn on the support lines, and I'm just going to take this one and I'll cut this up and delete 0.1, 2, okay, there's support line 1. That's a two-way slab. Now I'm going to add support line 2, and then support line 3. There's a break between these, and this one I'm going to relabel as a beam. I'll go to design and say, okay, now I want this to be more direct in terms of its rebar output. And I'm also going to add a splitter now because these points that coincide stop inside of the slab. So I'll just add this splitter and this one. And I'll regenerate the strips. And when I design this, and this one, you'll see this is still a beam RC, but when I generate the rebar will be more directed. Notice it's actually shown in the beam. It's a number 8 bar, and this becomes a little more clear as to what's happening for the design of that design cut as a beam. Okay, and if we go into that input here, this will give me, relative information with respect to that T section and beam. If the other question comes up, what about effective flange? And in the next iteration of the program, there will be options to determine the effective flange of a beam design strip. So when this is classified as beam, the program will actually automatically calculate the effective flange, or the user can override that option. In today's version, I would actually have to add splitters in order to impose an effective flange. So maybe I want this to be the flange of the beam. Let me see if I can grab that. Okay, and now I'll regenerate, and this becomes the width of the beam section. Now we have a portion of the slab outside of here where we don't have anything being designed for. So we would have to add another strip potentially here in order to get reinforcement designed out in that zone. Okay, so that's just a illustrative couple of examples there for the purpose of support lines, and and how we can handle beams within Builder along support lines. Let me go ahead and open the model. I'll save that, and we'll go back to this model that's a little more complex, has a few more things happening here. So the first thing is we have a series of walls kind of in this main core area, and we may want to just avoid that core completely in the design of this slab. Let's say we're going to design all of these beams and landing slabs elsewhere, and we want to avoid having anything happen in there. So to do that, we would use splitters. I'm going to show how we can avoid having anything go on in that core, and then I'll come back and we'll open it back up and actually add support lines. So this, by and large, is a two-way slab. I just showed you how to add the support lines for beams. I'm actually going to use that approach in this example. And there's also a pour strip. There's a pour strip here that's just designated by a couple of lines, and we may want to terminate the support line at the pour strip. We could also go through the pour strip, and we're going to assume that this is a PT slab, but the pour strip needs to be designed as RC. So if we go through this pour strip with a support line, we're going to get a design cut in these regions. This design cut will be designed as PT. This one will be designed as PT. This here will be designed as RC, as long as there's no design or no post-tensioning cable going through it. So I would anchor my post-tensioning this way, and this is too short of a span, but maybe I have PT this way. There's a gap, and this then automatically is designed as an RC two-way section cut. So in this example, I'm actually going to take the support lines through the pour strip, and I'll start. I recommend when you're setting these up to set them up consistently. I always like to go left to right. Otherwise, if you go left to right and then right to left, the text on some of your diagrams will actually be upside down, like the bending diagram or the stress diagram. So go left to right and maybe top to bottom when we're doing the Y direction. So we'll just give you an example here of breaking this slab up. So we'll start. You're going to see me start outside of the slab, and that's just to that is really just to avoid having to zoom in and out. No. One other thing that I failed to mention in that other example, I'm going to go back to it just briefly, is the need for support line vertices. Okay, so we're going to let's look at this support line here. Let's say that this is a two-way PT slab, and the question comes up pretty often: do we need to add these points on supports? They should be near supports. Technically, they do not have to be on the support unless you plan on exporting the strip to adapt PTRC through our integration item. If you open the program with that export option available, then you have to snap on actual location of supports. So there's a way you can model this support line with 6 support line nodes, or maybe just 2. I could go from here all the way over to here. What's the difference? In terms of the strength design, there's not much difference. I'll show you that now. So if I come back and let's say I design this for strength only, not for service. If I take this one, let me analyze the model for strength dead and live. And then I'll process this one. Okay, and I'll just turn on the bending diagram for this one strip here. We'll go to, okay, we get a diagram, we get a moment here, 72, and this is roughly negative 110. These are the max min along the strip. I could show all of them by using the numerical display setting. And if I generate the rebar for strength dead and live, we get something. Everything here is shown parallel to the strip. So all of the rebars broken up based on the support location, the span. The green rebar is top rebar, the bottom is red. So we get something that looks like this. We have 11 number 5s and 13 5s in midspan and the interior right side of that span. If I take this same strip and I'm going to remove some points here, I'll delete the vertices 1, 2, 2, 3, and 4. And I just say, okay, I'm gonna just place that something like this. And I generate the design strips. Notice there's less design cuts because the program develops the design cuts on a premise of 12 by default per span, and a span is a distance between two support line nodes. So if I want to change that, I say, okay, I want pretty much the same distribution. I'll just take this and say I'm going to bump that up to 36. The program knows where there are supports, so it will place 2 on either side of, or 1 on either side of the support automatically. So this will give me a better distribution in tune with what we had previous in terms of the number of design cuts. And if I design this for strength and I check the bending moment, the bending moments are close. I think it was 72 and 110. It's 66 and 102. So the difference is based on the integrated length, and in the other example we had a design cut that may have been at an angle. So we have some small difference in those results, but overall the program can develop the proper bending diagram even if you only have 2 points on the support line. If I generate the rebar for the support line, we'll go back and calculate the rebar for strength. You'll notice the rebar gets combined in some respects. So this top bar gets combined because of the presence of only 2 support lines. And what's probably happening there is if the 2 bars overlap, if there's a need for reinforcement, right, let's say on the top here, and it overlaps here, the program will just take those and combine them. This does not get combined because there's no overlapping of bottom bars in this span, nor in this span or this span. So this is isolated, and then these bars get overlapped again because of the overlapping of top bars. So the rebar layout becomes a little bit different when you model it this way, but still you get a safe design in terms of strength if you do this. The problem comes where you model this only with 2 points in terms of service. If there is a service related requirement by code that is dependent on the span length, for example, 2-way PT slabs at the prescriptive rebar at the top or at the support is based on the tributary in either orthogonal direction. And when we calculate that in our program, we're actually using the distance between points between the span. This right here from point A to point B becomes the span. So when I calculate minimum rebar for a 2-way slab, you're going to get way more rebar and incorrect rebar if you model it this way. In addition, you will also get incorrect values for deflection along the span or along the strip. So let me turn the reinforcement off here, and I'll turn the moment off. And if I go to deformation, I would have to generate this for service, but this would show, for example, L over 500 or whatever the value is. That span that it's calculating on is based on this full distance, which is incorrect. It should be based on the span between supports. So there's a few things that will be proper if you design it this way or if you set it up this way, and there's other things that will not, that would lead you to go back and break this up basically per actual location of a support. So that's important to know. We see models that come through that look like this in the rebar. We get questions on reinforcement or deflection, and this is usually one of the reasons why you see that. So let's go back to our main model for the remainder of the time. I'm going to break this model up again. This is going to be kind of manual input of the strips and the X and Y. We do have a wizard here that works well on less cut up slabs. So I'm not going to use that wizard. It's going to become obsolete in the future, just in the next couple of months. In the next release, we're going to have the availability of a support line editor where you will basically just draw a polyline, and the program will just pick all the supports on the polyline and draw the strip. The only reason in the next version you will need splitters is to bound the edge of the tributary to a certain width. In other words, all the splitters that I put in that previous example, 90% of those will no longer be needed in the next version. There will be options again for effective width for beams. How do we treat walls? Walls will become or can be tagged as a boundary, so the design tributary can go right up to the wall and stop before it crosses the wall. So there's a lot of different things coming, a lot of improvements for more rapid generation of the strips. Unfortunately, you're stuck with the old-fashioned method here. So I'm going to start at the top, and I'll just work my way over. If I have too many snap tools turned on, it becomes cumbersome. So all I like to have on really is snap to endpoint and snap perpendicular. And we'll go back and we'll adjust the support lines that I leave outside of the slab. So here we have a kind of a discontinuity because of this edge in the slab. So I'm just going to create a new support line like so. Again, this is something we could, I could probably go up like this, or I could just stop this one also, let's say here, and I'll start a new one along there. This is probably the more common way you see these slab edges with lots of ins and outs, is how I'm processing this one. I'm trying to keep everything in such a way that when I create a design cut, all of my distributed tendons intersect the design cuts at close to a 90-degree angle. For banded tendons, it's different because banded tendons might swerve and sweep more so than uniform, and in that case, we would kind of follow the same path as the bands. So here we're going to I'm going to go down to the center, close to the center of this wall here. Let me turn on the snap. There we go, midpoint, not intersection. So I'll just continue and just snap to the midpoint of each of these walls. Okay, notice I'm going through the pour strip. Now remember, my core, I'm going to avoid having anything go on in the core to begin, and then I'll come back and look at that more closely. So we'll come and skip down to this support line here. Okay, this support line will likely just bend over and follow this path of supports. Then I'll close it off like so. We have a column just sticking out here, so I'll just start this behind the column and work my way over to these other supports. We have another set of walls and beam. In this case, this is the first beam I think we've encountered, so I'm going to set this up similar to what we did earlier. I'll start this at the edge of the wall, I'll stop it, and then I'll start this at the beam, and I would have to tag those as a proper design criteria type. This would be beam, these would be two-way slabs. I will add one, let's say here. I'm going to extend that out just so it projects up to cover this corner of the slab that slopes on the edge, and then again we have another beam. So in this case I'll just run it continuous for some variance of the strips. So now we have our setup for the X direction. Okay, now again I want to avoid any strips in this core area. So we actually, let me add one more for this wall down below. So what I'm going to do first is I'm going to bound the edges off with splitters. I'll add a splitter that starts here. Remember this point is inside the slab edge, so I'll just run that up vertically and run it down to the support line. It has to extend either to a slab or another continuous support line. On the other side I have something a little bit similar, I believe. Over here I'll do vertically up. This stops in the slab edge, and vertically down. I'll do the same here, but this is actually going to, I'm going to add a splitter all the way along here without that weird kink in it. Same thing here, and that bounds out this entire zone. There are no support lines in here. This basically becomes void of having any design cuts in it. And then I can go back and fill in the rest of these splitters right here. Okay, so we'll do that first. So I'll use my X direction splitters. I'll start at this point and I'll just move this up. Now I may not want it to snap at the midpoint or perpendicular, so I'll use snap to nearest so I can try to align it vertically like so. There's the first splitter. The second one will be like so. And then I'm going to create the splitters all the way across. So I'm going to bring these slightly outside of the wall so none of my design cuts enter into the wall. And that's important if you don't want the program will not design for a cut that intersects a wall in terms of strength, or it won't calculate stress because it assumes the cut is over a support, which is a wall. So that's something you have to be mindful of when you're setting these up. And there's the first one. The second one I'll say is from there all the way over to too many things that it's trying to snap to. There's a second. That completely eliminates that region from the slab. Okay, now we're going to go ahead and finish these support lines up. This one I'll just chain up to the boundary on the walls or on the core. This is going to extend vertically and down to here. That closes that off, creates that boundary. And then we'll have a few up here. This one is not going to go up to the support line because there's a slab edge right there. So I'll just snap to that corner. The same thing here, but I'm not going to reach it over. I'll actually go up to the support line above and below, corner of slab, and then the support line. Okay, so this is one alternative to this, the more simple alternative, I'll say. And if we generate the strips, it says that there's some design cuts missing. Oops, this is trying to design add middle strips, so let me close it. When I switched modes, it switched it back into RC mode. I need to go back into PT mode. just go ahead and delete and regenerate again. Okay, there are two support lines, 432 and 434, that are not creating any strips. So if I search by type under Home, select by type, support line 432 and 434, I think it's these two over here. I forgot to add splitters there, so that's where I broke up that beam. I'll just go ahead and add those now, and this becomes hard to see because the points are so close, but you can snap between them to the slab edge, and then from this one down to here. Same thing right there. We'll snap between them, and then again down to here. Okay, now when I regenerate the strips, we should not get that warning. We got one warning. I'll have to look at that. There's some overlap. This is being overlapped on top of this support line here. So I'll check that. It's just a minor issue. So notice these design strips go, or design sections rather, go all the way up to that boundary right there. Okay, and I could add additional splitters if I want to actually maybe extend this only to the true tributary, because you do have walls along this path which are supports. This is one way to void out a complete area of a slab when you're designing and processing the slab. We're about out of time. I'm going to go back and just show in this X direction what we would do in this case where we have all of these walls in the interior. So I'll go ahead and delete the design strips, and I'll delete out this splitter. We're going to delete out a few splitters. I'm going to delete this one, and I'll delete that support line. Okay, now we're going to add support lines along this interior path. So we'll go back. I'm going to just combine the beams with the two-way slabs just for sake of time, but you'll notice I'm just snapping on each endpoint of the beam. If it's a long cluster of segmented walls, you could technically go from one end to the other. Here I'm snapping on each segment. We get back into a beam line along this path. So we're just running this completely continuous on one side of the core and the other. And the most important point here will be what happens with openings, and we'll conclude with that discussion. Okay, I'll go over here to this wall, and then I'll terminate that like so. The same thing will happen along here. For sake of time, I'm actually going to just run that all the way over to there, and then I'll stop it, let's say right there. Okay, and I'm actually going to double click on this strip and increase the count to 120 design cuts. We need to go back now and add the splitters based on this new layout of support lines. So we'll do that. The most important thing here is I'm snapping on all of the points that terminate within the slab. So I think there's one more right there and one more here. We have many openings in this core. You can see most of them. The best way to see them is to go to the select by type. These are all of our openings in the core. Okay, so when a design cut enters an opening but does not exit the opening, then it's not as important to actually bound off the opening. You can have a design cut that goes into an opening and there's no concrete there, so the program can't integrate a node where there are no nodes. So that it's acceptable to have a support line or a design cut enter an opening. So when I generate these strips here, you're going to see that happen along this middle portion. If I look at these design cuts and I go back and select by type the openings, you can see the design cut goes into an opening. Here on either side there's an opening, for example, right here. This cut enters one side, this cut enters the other. That is acceptable. The problem you want to avoid is if an opening is positioned and the design cut actually goes all the way through the opening. That becomes problematic because the program is taking a design cut that physically you have a slab on one side and a slab on another, and there's an opening here, and it's taking these two portions of slab and it's creating what's called an idealized design cut, which combines them. So now it's integrating the actions here and here on two sides of an opening and saying, okay, for that integrated and resultant set of forces, shear, moment, axial, whatever is happening at the centroid of this idealized cut, here's the rebar and here's the stress check. And in reality, there's a discontinuity there. So to handle something like this, you have to add, you have to use splitters to kind of bound off the opening and generate the proper set of design cuts. Okay, so what I'll do in this example, I'm actually going to delete this one so I can force it to do just that, and I'll just stretch these up to the support line that's left over. And now we're going to generate the strips, and you're going to see cuts going through openings. So now this cut goes all the way through this opening here. So how would we generate support lines in this case? What we would do, and I'll do it just for this opening right there. I'm going to create splitters again. These are X direction splitters. I'm using the corners of the openings because they're easily snappable points just to align my splitters. So I'll just start at this side and I'll go from this point to this point up to the support line, to the same on that side. Okay, and now I'm going to create a boundary. I'm going to say for this support line below, I want it to stop at this splitter that I'm adding. It can't cross into the opening now because there's a boundary there. And likewise on the opposite side, I could put another splitter, let's say from that support line over to the one on the opposite side. And this will stop at that boundary. Nothing will happen in this zone because there's no support line there. So once we generate that again, you should see that cut out now. So this stops, it doesn't go all the way through, nor does this one. This stops here and doesn't go through the opening. So you could add multiple splitters at each one of those openings. All right, I apologize for going over a few minutes here. I'll go ahead and close with that, and I appreciate everyone's attendance. I'll add this to the YouTube channel, and if there are any questions, go ahead and you can type them now into chat. I'll just take the next few minutes to answer any questions. For those of you that need to leave, again, thank you, and we'll have one more webinar next week that will cover I think it's going to cover wall and column design. I can't remember, but there is one more webinar at the same time next week. So thank you. All right, any questions? I'll just wait a few more moments here. If there's nothing that comes in, we'll go ahead and conclude. All right, no questions. We'll go ahead and stop there then. And if you do have questions and you think of it afterwards, feel free to email support@adaptsoft.com. And everyone have a great day. Thank you.